Let us look into the fourth chemical reaction, that is, double displacement reaction. Double displacement reaction occurs when two elements displace with another other two element in the reactants to produce two new products. In double displacement reactions, element get displaced with the other element on reactant side. The general representation for double displacement reaction is A, B plus C, D gives A, D plus B, C. Please note that double displacement reactions usually occurs in solutions by producing insoluble products and precipitates. Here is an example for double displacement reaction. Example 1. For double displacement reaction between two solutions or compounds, the word equation is silver nitrate plus sodium chloride gives silver chloride plus sodium nitrate. Here on left hand side silver nitrate, sodium chloride, that are compounds, are called reactants, and right hand side silver chloride, sodium, which are compounds, nitrate are called products. The chemical equation is: in this reaction, two compounds, silver nitrate and sodium chloride, react to form two new compound, called silver chloride, and sodium nitrate. Please note that double displacement reaction occurs on exchange of ions to form new products. Exchange of ions will be discussed in detail in next lessons. Now we will do an experiment to understand double displacement reaction. The experiment is about formation of barium sulfate and sodium chloride. We need only 2 test tubes for this experiment. The chemicals required are barium chloride, sodium sulfate, and dilute HCl, or HNO3, or H2SO4. A precaution to be followed during the experiment is, add barium chloride slowly by continuous shaking of the test tube. Let us start the experiment. Take one test tube with 3 mm of sodium sulfate solution. Take another test tube with 3 mm barium chloride solution. Mix the two solutions. What do you observe? As soon as sodium sulfate is mixed with barium chloride solution, a thick white precipitate is formed, which settles down at the bottom of the test tube. Test the solution with dilute HCl, or dilute HNO3, or dilute H2SO4. What do you observe? If the reaction mixture is treated separately with dilute HCl, or dilute HNO3, or dilute H2SO4, we observe that the white precipitate does not dissolve. Conclusions of this experiment is: the white precipitate is called barium sulfate. The white precipitate formed by the reaction of sulfate and barium, and the other product, is sodium chloride, remains in the solution. Hence, the reactions in which there is an exchange of ions between the reactants are called displacement reactions. The chemical equation of this reaction is: here note that any reaction in which insoluble solid, that is precipitate, formed is called a precipitation reaction. Let us do another experiment to understand double displacement reaction more clearly. The experiment is formation of lead iodide and potassium nitrate. We need 2 test tubes for this experiment. Chemicals required are lead nitrate and potassium iodide. Precautions to be followed during the experiment is: add potassium iodide solution slowly to lead nitrate solution. Let's do the experiment. Take one test tube with 3 ml of lead nitrate solution. Take one test tube with 3 ml of potassium iodide solution. Mix the two solutions slowly. What do you observe? As soon as lead nitrate is mixed with potassium iodide solution, a thick yellow precipitate is formed, which settles down at the bottom of the test tube. The conclusion of this experiment is: the yellow precipitate is called lead iodide. The chemical equation of this reaction is: let us do one more experiment to understand double displacement reaction. The experiment is reaction of sodium hydroxide with hydrochloric acid. The apparatus required are test tube, Conical flask. Burette. Chemicals required are dilute hydrochloric acid, dilute sodium hydroxide, and phenolphthalein solution. Precautions to be followed during the experiment is: hydrochloric acid is corrosive in nature. So, take dilute hydrochloric acid, is one which contains much more of water in it. Let us start the experiment. Take dilute sodium hydroxide solution in a test tube. Add few drops of phenolphthalein solution to the dilute sodium hydroxide, and observe the change. What do we observe? We observe that dilute sodium hydroxide solution color changes to pink color when phenolphthalein solution is added. Add dilute hydrochloric acid solution to the above solution, that is pink solution, drop by drop, and observe the change. What do we observe? We observe that pink color in the solution disappears on adding dilute hydrochloric acid solution. Add few drops of dilute sodium hydroxide solution to the above mixture, and observe the change. We observe that we get back the pink color in the solution on adding sodium hydroxide solution to the final mixture. The conclusions for this experiment are: after adding a certain volume of phenolphthalein solution, that is dilute hydrochloric acid, to sodium hydroxide, observe all sodium hydroxide base, taken in test tube, has been completely neutralized by the dilute hydrochloric acid, by which we can conclude that it is neutralization reaction. The general and chemical equations of this reaction is: the word equation is base plus acid gives salt plus water. The chemical equation is: here we should note that the process of forming soluble solutions without forming any precipitate is called neutralization. In neutralization, acids and bases react to form salt and water. The reaction between acids and bases to form salts and water are also called double displacement reactions.